we talk today about a lovely word, complementarity. So complementarity then. Now, this was a principle that Niels Bohr came up with way back in the dawn of time as far as quantum mechanics is concerned, to encapsulate the behaviour of quantum particles. So the way I've drawn it here on this Heath Robinson flip chart is probability coming in from the future into this is hourglass effect. And the probabilities that are streaming in are the probabilities that we then experience as reality as we go through our world. Wave particle, that's a very famous one indeed. And that was an actual experiment called the double slit, and it proved that particles will turn into waves if they're presented with the right piece of equipment. So that came on the scene, and it still is obviously very much a fundamental quantum principle today. Then you've got causality and retrocausality. Causality is what we experience. We tend to experience the flow of time as we perceive it, going from past to future in this sort of forward motion format. But what we're actually experiencing is entropy. We're not really experiencing time, we're experiencing entropy, the decay of a system. And that decay of the system, with the way the universe is constructed as far as we perceive it, goes in one direction only. But retrocausality proves that that's actually not the case. Retrocausality proves otherwise. Causality essentially is what we experience as we move through the timeline. We experience entropy, in other words, cause and effect in the way that we perceive it. So it has something of a linear format, it seems to be going in one direction. And that's entropy at work, that's what we're experiencing. But retrocausality, well, that's a different kettle of fish, because that's the backflow, it's the reverse of causality essentially. What retrocausality describes is the waves from the future, i.e. the future, coming in and becoming the present and affecting the past. So that's harder to get your head around. It's a different kettle of fish when you turn it around into that direction. But in fact we do experience retrocausality in everyday life. You're effectively retrocausally branching time. You're going off into a different trajectory because of your change of perception of that event. If you think of an event that's happened to you in the past somewhere, something that's really gone deep, if you were then to receive some information that changed the truth as you perceived it of what that event was, you're going off into a different trajectory because of your change of perception of that event. It doesn't change the event per se from having happened, but it changes its impact on the future. That's how it works in our world. It doesn't happen all the time. What happens all the time is this causality effect, i.e. the particle reality, the particle side of wave-particle duality. But hey, we've got a singularity to work from, and that essentially is the perspective that we have. Now in physics, the singularity, as we know, is a point in space-time beyond which nobody knows what there is. So we don't really know what a singularity is for sure, certainly not in mathematical descriptions, but the evidence stacks up to suggest that they do exist as individual, unique things. We are singularities in our own right. That's as much as we know about singularities, really. They're interesting and elusive things. Unitarity is the other end of the scale. Now, were we to have a grand unified theory come about, which is the scientific holy grail, that's what everybody's looking for, is the GUT in capital letters. Hey, something's telling me that then you've got to go with your gut, and it's going to take a lot of expansion of mind, let alone expansion of the universe, to get these principles together in some kind of unified way. Were it to materialise, and there were to be a grand theory unifying everything, then that would qualify as unitarity, and we would cease to be so singular perhaps in the way we view things, were that to be the case. So there's those two on the ends of their equation. Coherence and entanglement. Coherence is a pure trajectory. It's an unfettered form of travel, a pure form of energy. A laser beam is a beam of coherent photons, and there is coherent water in the microtubules of our brains. The photon is actually a really good example of coherent light being able to do things that incoherent light cannot. For if you create a laser beam out of photons, you're making it from coherent photons. They are all working in unison as one in a very, very powerful way that can cut through steel. Whereas the light that's coming out of a light bulb really can't do anything other than burn your hand a little bit if you touch the bulb. So coherence is a very pure thing, whereas entanglement is a mess, really. Entanglement can happen to any particle anywhere in the universe, regardless of its distance, its separation from all the other particles, and still respond identically in exactly the same way, in exactly the same time as its partner particle. You've got two particles in the simplest form of its expression. Two particles can be anywhere in the universe. There can be any distance at all between them, and they will react instantly, simultaneously, in fact, to stimuli that one or other has experienced. Quantum entanglement can be used in all sorts of ways, and its exploration is obviously very beneficial to various forms of technology and science. But in the human context, it's probably just fair to say that entanglement can happen to people. Momentum and position, well, these are the underpin of the uncertainty principle, that we cannot measure one thing or the other at the same time. Not knowing what the speed or the trajectory of something is at the same time as knowing what position it's in. So if you know where it is, then you don't know how fast it's going. Now, I'm of a mind to suspect that the uncertainty principle actually goes an awful lot deeper than that, and that it underpins the uniqueness of everything that is. We know from our experience that uniqueness exists in the most amazing array of things, such as snowflakes and grains of sand, because the atomic structure of them coming together and creating what they are essentially is a continual variable as to all the permutations of everything that goes into making up that snowflake or that grain of sand. Equally, we identify with uniqueness in our own right as human beings. Uniqueness spans potentially everything. In fact, we can't tell how far down uniqueness can possibly go. We can see it in our own species, but we're hard pressed to see it in other species. For example, this is a tawny owl. And he's unique as a tawny owl. There is no other tawny owl who looks exactly like him. But we wouldn't be able to tell that, because we will look at all tawny owls and see a tawny owl. That's what they look like. There are drawings in the books that tell us what they look like. In fact, that it's not as simple as that. The feather structure of what's on his plumage and the way he looks is unique to him. So momentum and position are essentially the two sides of Heisenberg's uncertainty principle in terms of the way the science puts it. These two are descriptions that I stumbled across when I was looking for dictionary descriptions of complementarity, because they're always useful. Interrelation of reciprocity, reciprocal, reciprocal stuff, we'll call it. It's easier to say. That's a kind of symbiosis. That's the symbiotic nature of two things that really have to coexist, because they cannot not coexist. It cannot be any other way. You can't have the wave without the particle. You can't have dark without the light. You can't have positive without the negative, and so on. So this is the interlock, the interface of symbiosis that brings everything together. The other description I found on the same dictionary website, which was quite amusing: opposing states cancelling all possibilities. So that's a million miles away from symbiosis. That's like the juxtaposition of how far away can you get. The creation of this version of reality seems to be stalled by a juxtaposition that exists in ways of thinking about the quantum world. On the one hand, you've got this symbiosis that has to occur, and on the other hand, you've got this completely opposing state of standoff. Do not enter here. Yeah. So these two extremes are still complementarity. That's how the paradox of the quantum world works. That is the nature of the beast. This is going back to grand unified theories. Can the grand unified theory be achieved? If it can, I think it would solve a lot of this disparity between the points of view that seem to be ruling at the moment. Just as an experiment, I've drawn something here, and don't know what you'll make of it, or what you imagine it might be. But if you then sort of have a look and take your eyes away from the image there, you will create in your mind an image of something that's real, that your mind perceives as real, based on the information that this picture gave you. And that essentially is how our imaginations work. Now, in reality, this is nothing more than just some squiggles in different colours on a bit of paper. It doesn't represent anything real at all, in terms of what you would imagine it to represent. So the coming together of these terms and the complementarity of the ways of thinking, the various methods that we could use to explore these paradoxes, it's a bit of a Pandora's box, and let's hope that it's got nice things in it, because I firmly believe that it has. We're done with horrible things coming out of Pandora's boxes. Let's have some nice stuff now, and open up minds, hearts, thoughts, and systems of thinking to ways of bringing this quantum field and our reality together. So enjoy your journey. Thank you very much for staying with me this far, and I hope to see you again soon. Take care. Bye.